Very small recap of the last video. So in the last video I have told you beforehand we do not know what is the burst time of any process, and also we have started solving the problem, okay, by assuming we have all the burst times of each of the processes. Okay, this is a contradiction. So I have already told you these are not exact burst times because we cannot know the exact burst times. So what are they? These are the predicted burst times. Okay, so in this video I will be showing you how can we predict. So in order to predict we have two way. Okay, one is static way, okay, one is dynamic way. Okay, fine. So static way has two parts. One is predicting the burst time by looking at the process size. Another one is predicting the burst time by looking at the type of process. Okay, how can we predict the burst time by using the process size? Let's say in the past one piece of 1 MB process came to your OS and your OS has measured after 1 minute of execution this process was finished. So your OS knows this 1 MB process had the burst time of 1 minute. Now in future when this similar 1 MB of process comes again, now your operating system will predict, oh, last time on 1 MB process took 1 minute. So this is also 1 MB process. This may take also close to 1 minute. So now your operating system will estimate the burst time of this new process, new 1 MB process to be 1 minute. This is how we predict the burst time by looking at the process size. So this is a very bad way of predicting burst time. Why so? Let's say there is a process 1, process 2. Process 1 is having 1000 lines of code and all the lines of codes are important. Okay, process 2 is having the similar number of lines of code, that means 1000. Okay, so as a result the size of these two processes are same, but the catch is, let's say after line number 2 there is a case if false, and then what's happening is line number 3 to line number 1000 under this if condition, that is if false, what will happen? Line number 3 to line number 1000 will never get executed. Only line number 1 and line number 2 will get executed. So in process 1, 1000 number of lines are getting executed. In process 2, only 2 number of lines are getting executed. Even though size of these two processes are almost same, but what do you think? Burst time will be same or not? Burst time will be significantly different. Here 1000 number of lines are getting executed and here only 2 lines are getting executed. Alright. So similarly, burst time of P2 will be much more lower than burst time of P1. So predicting the burst time by looking at the process size is never a good choice. Now there is another static way of predicting burst time, that is type of process. So there are multiple type of processes. One is operating system type of process, that means the process that is created and handled by operating system, example is dispatcher. Okay, one more type of processes might be foreground that runs in front of your eye, and one more type of process is background process like virus scanning, okay, some kind of backups. These are the background processes. Okay, so while you are doing something else in background, these processes keep on running. So the next type of process is real-time process. Okay, so that is airbag system of a car. Okay, so the moment the system detects a collision, immediately it has to deploy the airbags. Okay, let's say with thousands of examples, okay, now your operating system knows if a process is from operating system, okay, that may take 1 to 2 seconds. If a process is type of foreground process, that may take 6 to 8 seconds. If a process is a type of background process, it may take 10 to 15 seconds. If a process is a real-time process, it may take 1 to maybe 1.5 seconds. Similar type of process comes, your operating system checks which type of process it is, whether it is operating system process or foreground process or background process or real-time process. Okay, seeing that your operating system decides, oh, generally foreground processes take 6 to 8 seconds. This coming process is a foreground process, so this coming process will also take 6 to 8 seconds. Okay, if that is a background process, your operating system will understand background processes are generally taking 10 to 15 seconds. So this is a new background process. This new process will also be running for 10 to 15 seconds. So that is how, by looking at the process type, sometime your operating system can predict the burst time. Okay, so this is also not a good option to go. Okay, now these two are the static way. So now let me show you some dynamic way of predicting the burst times. All right, so the first one is average of previous CPU burst times. Let's say 1000 number of processes your operating system has already executed. Okay, so by this time your operating system knows how much burst time each of the process took. Okay, so when the next process comes, what will happen? Now your operating system will check the burst times of all these 1000 processes. Okay, and will take the average of all these burst times and will predict that 1001 this process is having the burst time which is average of all the previous burst times. Okay, so the predicted burst time of process n plus 1 is the average of all the burst times seen so far. Okay, how is that calculated? Take the summation of all the burst times and divide it by number of processes. Okay, so that is how it predicts the burst time of the next process. So now let's see one more dynamic way of predicting burst time. Okay, so let's say this Ti is the burst time of process what? Pi. Okay, so this tau n plus 1 is the predicted burst time of process n plus 1. Alright, so the equation says tau n plus 1 equal to alpha into Tn plus 1 minus alpha into tau n. So it says alpha into the actual burst time of previous process plus 1 minus alpha into the predicted burst time of previous process. So now let me take one more example, okay, to explain the dependency. Okay, so tau n plus 1, okay, depends on tau n and Tn. All right, again tau n depends on tau n minus 1 comma Tn minus 1, Tn minus 1. This tau n minus 1 depends on tau n minus 2 and T of n minus 2. Alright. So that is how you can see. So at n plus 1, whatever burst time you are predicting, so it depends on all the process from beginning. Okay. And all these processes T and tau both actually plays a crucial role in predicting tau n plus 1. Alright. So I have written this thing in this example. Tau 2 depends on tau 1. Tau 3 depends on tau 2. Tau 4 depends on tau 3. Okay. Something like this. So tau n depends on tau n minus 1. Okay. So this tau 2 depends on what? T1. This tau 3 depends on what? T2. Okay. Again, while predicting the burst time of process n plus 1, we will have to see all these n processes and all these n processes. Okay, what was the actual burst time and what was the predicted burst time. Okay, so now let me show you some examples so that things become very much clear. Okay, so tau n depends on all predicted taus and all actual t. All right, so value of alpha decides you want to be more biased towards the actual burst time of last process or the predicted burst time of last process. Okay, so if this alpha is equal to 0, what will happen? Tau n plus 1 equal to 0 into Tn plus 1 minus 0 into tau n. So that will become tau n. So when alpha is 0, then you are saying, so when alpha equal to 0, so while predicting the burst time of process n plus 1, you are saying whatever burst time I predicted for process n, okay, here also I am predicting the same burst time. Alright, so you are taking the previously predicted burst time and you are predicting or estimating this process n plus 1 will be taking the same amount of burst time. Okay, so this is something. Then when alpha is equal to 1, what will happen is tau n plus 1 will become 1 into Tn plus 1 minus 1 into tau n. So this tau n will be becoming 0. Alright, so this tau n plus 1 becomes Tn. So what will happen? So in this case, when alpha is equal to 1, while predicting the burst time of nth process, you are saying I will not be doing any hard work. What I will be doing? I will be seeing the previous processes actual burst time and I will predict that this process will be taking the same amount of burst time. This is the prediction. Okay. So in a single line, the burst time of process Pn plus 1 is estimated to be the actual burst time of the previous process. Alright. So when it is? When alpha is equal to 1. So now there is some SHM kind of thing, that is simple harmonic motion. So at one side there is Tn, another one is tau n. Alright. So while predicting this tau n plus 1, okay, alpha is the moving factor. What it does, it moves the tau n plus 1 either towards Tn or towards tau n. Okay, it all depends on the value of alpha. Okay, so now let me take some example. Say in your system you have already seen these two processes. Okay, and you know the burst time of these two processes. So now what you will have to do, you will have to predict the burst time of tau 3, that is process 3. And let's say this alpha is given in the question, okay, and this tau 1 is also given in the question. Okay, so what you will do, what is the value of tau 2? Tau 2 is alpha plus T1 plus 1 minus 0.5, that is 0.5 multiplied by tau 1. Okay, just put the corresponding values. See, tau 1 value is 2, I have put the 2 only. Then tau 1 is 3, I have put the 3. So 0.5 multiplied by 2 plus 0.5 multiplied by 3. So this will become 2.5. So you will predict this tau 2 will be 2.5. Okay, but your target is to calculate tau 3. Okay, so why did we calculate tau 2? Because while calculating tau 3, we will be requiring this tau 2. So on the first place, we have calculated this tau 2. Now let's move to next step. So now tau 3 will be alpha into T2 plus 1 minus alpha, that is 0.5 multiplied by tau 2. Just put the corresponding values. Okay, tau 2 will be 2.5, T2 will be 3. So this will be becoming 2.75. So this is the answer. Okay.